class, Dr. Barnes here. Let's talk about the properties of Fourier transforms. Continue our discussions on this particular topic. Okay, so let me write here properties of Fourier transform. This shall be the part 5 of this particular property. And here I'm going to consider the time scaling property. Okay, so in the time scaling property, okay, this is property number, I believe this one should be our property number 12. Okay, so here, if I have x of t, if I have x of t, which has a Fourier transform of x of what? Omega. Okay, then if I have x of what? At, it is also going to have a Fourier transform of 1 on what? Mod a into x of what? Omega on what? A. Omega on a. Okay, so this mod a, modulus a, I have to take both the positive and the negative what? Aspect of it. Okay, so in that case, I'm going to consider the case in two different scenarios. So I'll consider case 1. So case 1 is such that a is greater than what? 0. Okay, so a is greater than 0. So now here, Fourier transform of what? X of a what? T. Okay, it's going to be no, here please, I have to write equal to. Okay, yeah, I have to write equal to. It's going to be equal to here infinity minus infinity. Okay, x of what? 80. Okay, into e minus j omega t the what? The t. Okay, so now let me say that let tau to be equals to or let me say that let tau to be equals to my 80. Okay, then in that case, tau over a is equals to what? T. And then t is equals to what? The tau over what? A. T is equals to the tau over a. In that case, my expression can now change to infinity minus infinity x of what? Tau into e minus what? J omega a, omega on a, okay, into what? Tau. So here, you see this t over here, okay, t over here, I have written it as what? Tau on a, and then that is what is giving me what? Minus j omega on a what? Tau, okay, that is what is giving me there, because my t here has now changed. My t here has now changed to a tau on a. Instead of writing tau on a, I can bring the a here. It's the same. Okay, and here will become what? The tau because of here. But you see, when here becomes the tau, you see that here, sorry, it should be the t is equal to the tau on a. You see that here is the tau on a. So I'm short of the tau on a. But that a, let me bring it here so that it becomes 1 over a here. Okay, so now if you should compare this expression with this expression, you see that this at has become what? Tau. This t has become what? Tau on a. Okay, which is what? Omega on what? A. Is the same thing, you can write it. Okay, so this expression here is this expression here. But in this expression here, we know that it is what? Fourier transform, which is what? X of what? Omega. X of omega. So now I can bring my 1 over a here like this, and I can bring what? X of what? X of what? Omega. You see that the expression here is the same as the expression here, except for this a. Except for this a. So now, because of that a, I'll bring it here. Okay. So now your expression x of what? At, okay, is the Fourier transform. Is the Fourier transform, which gives you 1 on what? A. X of what? Omega on what? A. And this is for what? A being what? Greater than 0. Okay, and this is for a being what? Greater than what? 0. So let's see in the case whereby let's see case what? 2, whereby a is less than what? 0. If a is less than 0, then Fourier minus what? 80, because it's less than 0. Okay, it's going to give me here infinity minus what? Infinity. X of what? X of minus what? 80 into e minus j omega what? T the what? The t. So now here minus 80 is equals to what? Tau. So let, okay, minus 80 to be equals to what? Tau. And then t is equals to minus tau on what? On a. Okay, and then the t is equals to minus the what? The tau on what? A. So if I put these expressions here, okay, then I will have what? It will be equals to 1 over what? A into, let me wait on introducing my limit, on writing my limit. It's equals to x of what? Here becomes what? Here is what? This place. So it becomes tau. Okay, into e exponent what? This minus here will now become positive. It will become positive because this t is what? This t is now what? Minus tau on a. Minus minus becomes positive. So I'll have positive j. Okay, so t over a. Instead of writing t over a, I'll prefer to write it omega over a into what? Into what? Tau. Okay, so because t is now equals what? Minus tau on what? A. Okay, so the minus minus gives us positive, and then this tau is this tau. This a, I have brought it here, is the same. Into what? The t is now what? Minus the tau over a. But this a here is what I brought here. Okay, this a here is what I have brought here. Okay, so and this is the t. So but the t here, the minus the tau here, the tau here is minus. If the tau here is minus and the t here is positive, that means that it must have I can introduce this minus the tau. I will not write the minus here. I would rather let the minus affect the what? The limits. So you see that before here was negative infinity, but it will now become positive infinity. And here will become the negative what? Infinity, which was positive infinity before. Okay, so the negative the tau, which I was supposed to write here, I'd rather make it affect what? The limits. Okay, affect the limits. Okay, so basically this is how I have done it. It became minus infinity, x of tau, e, positive j on what? On a. Positive j on a. Okay, here is what? Tau. Here is what? The tau. Okay, so this one will give me, if you should compare this one to this one and the former one we did, you see that this one, except for this a which is here, it is the Fourier transform, okay, which gives you x of what? Omega. Okay, so this one will give me, this 1 over a will come here. Okay, so this is the Fourier transform. This x of what? Omega. The Fourier transform of x of tau, which gives us x of omega. So now I can write here x of what? Omega. And this a, I can bring it here. Okay, all right. So now what is going to happen is that you see that here is now positive, but in the normal Fourier transform, here is what? Negative. Okay, so now instead of negative, now it is what? Positive. That means that this place has to be what? Negative. Okay, so now this Fourier transform of x of minus at is now equals to 1 over what? A, okay, into x of what? Minus omega on a. Okay, so if we take everything, both the case 1 and the case 2, okay, then what we have is that we have x into what? 80, okay, which gives the Fourier transform of 1 on what? Mod a. Mod a can be positive or negative into omega on what? A. Okay, so it is proven by this. Thank you so much. See you in the next class.